Hey 7th graders, welcome to your 7th lesson. In our 7th lesson, we're going to be talking about constant rate of change. Our objective is to represent and identify if there's a constant rate of change. The standards we're going to be addressing is 7th grade, ratios and proportions standard number 2, 7th grade, ratios and proportions standard number 2B, and 7th grade, ratios and proportions standard 2D. Let's go ahead, copy our vocab, and start this lesson. For our lesson today, we have 2 vocab words for today. The first vocab word is rate of change. A rate of change is a rate that describes how one quantity changes in relation to another. So when we're talking rate of change, we're really talking about the change in the y values in comparison to the change in the x values. Change in y over the change in x. So try to remember that phrase, change in y over the change in x. That's rate of change. A constant rate of change is the rate of change in a linear relationship. So a constant rate of change means that your change in y divided by your change in x is always the same. If you always have the same number that it's changing by, then what's going to happen is it's going to make a straight line when you graph it. The word linear means makes a straight line. So it's the rate of change that makes a straight line when we graph it. A constant rate of change is always the same number when we have the change in y, change in x. It's always the same as we go across. Let's go ahead and practice some problems. In our first example, what we're going to do is we're going to use this table to find the rate of change. So it says the table shows the amount of money that a boosted club makes while washing cars at a fundraiser. Use the information to find the constant rate of change in dollars per can. So what we have to do is look at this table. First thing we want to do is we want to establish which one is x, which one is y. Because the definition of rate of change is the change in y divided by the change in x. Well, typically, when you have a table, the thing that you see first is considered to be your x value, and the thing you see second is considered to be your y value. Reminder, rate of change, or we're going to call it ROC, the rate of change is equal to the change and y divided by the change in x. So what we have to do is we have to figure out what does the y change by and what the x changes by. If it is always the same number on the right side and it's always the same number on the left side, then we have a constant rate of change. A constant rate of change means that our graph would be a straight line. A non-constant rate of change means our graph would not be a straight line. So let's just check. So since we know that this is the x and we know this is the y, the first thing we're going to do is find the change in y. Since this is the y, I'm going to find out what do I change by to go from 40 to 80. Well, I'm going to change by 40. What do I change by to go from 80 to 120? Again, I'm going to change by 40. 120 to 160, I'm changing by 40. So right now, the change in y, which is going to go on top, that's 40. So what we're going to do is we're going to say our rate of change, our ROC for rate of change, is equal to 40. And now, all we got to do is figure out what is going to be on the other side. Well, in the x, 5 to 10, that's a change of adding 5. 10 to 15, that's adding 5. And 15 to 20, that's also adding 5. So in this case, we're always changing by 40 on the right side, and we're always changing by 5 on the left side. That means we actually have a constant rate of change. A constant rate of change is when we always have the same number on both sides when we're looking at it. So our rate of change is actually 40 over 5. If you want to change this to unit rate to figure out how much money they're making per car, we know that they're going to make $5, or they're going to make $40 for 5 cars. So our job would be to figure out how much are they making per car. So since we know that our rate of change is $40 for 5 cars, we could use what we learned in lesson 1, and we could divide by 5 on bottom, divide by 5 on top. 40 divided by 5 gives me 8, and 5 divided by 5 gives me 1. So in their car wash, in the fundraiser, these students are actually making $8 per car. In this problem, we're going to be taking the table and finding the rate of change. We need to figure out the rate of change is constant. If our rate of change is constant, our graph would be a straight line. The table shows the number of miles that Claire drove on a trip. Use the information to find the constant rate of change in miles per hour. So they're telling us it is a constant rate of change. We just got to figure out what the constant rate of change is in miles per hour. Since we see the word miles, that means that's going to be our y value. And then we see the word hours, that means it's going to be our x value. So always understand that time is almost always an x value. So since I see time, this is going to be the x value, where the top is going to be my y value. Normally, though, when you see a table, what you see first is your x value, and what you see second is your y value. But in this case, since we have time, time is our x value. So what we're going to do is we're going to find the change in y first, because rate of change is the change in y divided by change in x. So I'm going to figure out what y changes by. Well, it goes from 130 to 260. That's a change of 130. It goes from 260 to 390. Again, that's a change of 130. And it goes from 390 to 520. That's a change of 130. So I know right now that the y is changing by 130. So I'm going to write that the change in y is 130. Now, all I got to do, find the change in x. Because, again, rate of change is the change in y divided by the change in x. So I look, it's going from 2 to 4, that's a change of 2. 4 to 6, change of 2. And 6 to 8, change of 2. And as they stated in the beginning of the problem, they said, find the constant rate of change. So they told us that this is a constant rate of change. Well, now looking at it, I agree with them. It's 130 on top every time, and it's 2 on bottom every time. So it is a constant rate of change. The rate of change is that you're going 130 miles over 2 hours. Well, now we have to actually figure out what it is for 1 hour. So since we have our unit, or we actually have our rate, we're going to change this into a unit rate. So all we got to do is divide by 2 on bottom, divide by 2 on top. Well, 130 divided by 2, okay, well, that should be 65. And 2 divided by 2 is 1. So I know that if you went 130 miles in 2 hours and you went 520 miles in 8 hours, that you're traveling at an average speed of 65 miles in 1 hour. 65 miles per hour. So this would be our constant rate of change. It's always changing by 65 miles every time we move over 1 hour. It looks like 2 here, but 130 divided by 2 gives me 65. 65 miles, 1 hour. Let's go ahead and look at some graphs now. On our next example, go ahead and take a quick second, take some time, try to make a really nice graph. I counted by 0.5s going up, so I started with 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. And I wrote that it's time, and time is represented by h, which is hours. And on the left side here, I talked about distance being miles, and I counted by 20s. So what, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. So what I did was I graphed this information. I said, okay, well, we're going to start down here at 0, 0. So this point right here is 0, 0, which is our origin. So this, we need to know what it means. So we're going to read the question. It says the graph represents the distance traveled while driving on a highway. So this graph right here represents how far you go when driving on a highway. Our job is to find the constant rate of change. So what we're going to do is we're going to find out the change in y and divide it by the change in x. Now, the y is anything that's happening on this side, where the x is anything happening on this side. Because rate of change is the change in y divided by the change in x. So I labeled the line that goes up and down, that's the y line. The line that goes left and right, that's our x line, or our x-axis. So we have the y-axis, the x-axis. But we know that rate of change is the change in y divided by change in x. And we can also see that this is a constant rate of change. It's a constant rate of change because we can see that it makes a straight line. If our graph makes a straight line, that means it's always changing by the same number. So all we got to do is we can look at our graph and determine what is the change in y, what is the change in x. So we know that rate of change equals the change in y divided by the change and x, which you've heard all throughout this lesson. ROC, rate of change, is the change in y divided by a change in x. So what we're going to do is we're going to figure out what does y change by. Well, starting out, we start at 0 and we go up till we hit 60. The next dot stops at 60. So the y changes by 60. Every time the x, and I'm going to trace this, so I'm going from 0 right here to 1. So I go from 0 to 1. So what's happening is I can tell you that the graph went up 60 till it got to this point, which that's the change in y, and then went over from 0 to 1, where that point is at, and it changed by 1. So the change in y is 60 over 1. If this is linear, which what we see is a straight line, then that rate of change would also happen here. So if I go up, how high do I go up till I get to the next dot? Well, it went from 60 to 120, which again is a change of 60. And then I check how far it goes over. Well, it goes from down here, it goes from 1 to 2 where that dot's at, so it's changing by 1. Again, the change in y, or how much we go up, changes by 60 every time the graph changes by 1 going over. Let's check again. Since it's a straight line, this should work one more time. I go up 60 spaces, so now I'm at 180, and that dot looks like it's at 180, so that's perfect. And then I'm going to check, I'm at 2, and I'm going over to 3. So since I'm at 2 and going over to 3, that's a change in 1. So what we did was we just proved that this graph changes by going 60 up, 1 over, 60 up, 1 over, 60 up, 1 over. So the change in y is 60 spaces up, the change in x is 1 space over. So our rate of change, well, looking at the y, that's 60 miles. Over, looking at the x, well, the x is changing by hours, so that's 60 miles over 1 hour. So now we know that our rate of change is 60 miles in 1 hour. Let's do one more problem and call it a day. You guys are doing awesome. Alright, 7th graders, for your final piece of the lesson, we're going to be talking about a plane flying and looking at a graph and finding our constant rate of change. Again, we know it's a constant rate of change because when we graph it, we get a straight line. Go ahead, take a minute, copy down this graph, put it in your notes. Also, make sure you copy down the word problem here, because that word problem is going to tell us exactly what we need to do. It says the graph represents the distance traveled while flying in a plane. Find the constant rate of change in miles per hour. So we again have to find the constant rate of change. We know it's a constant rate because it makes a straight line. So now we're going to find the change in y, and we're going to find the change in x, and we're going to write that as our rate of change. So we know that the left side is miles, and we know the bottom is hours. So we're going to figure out how many miles that the plane travels in how many hours. Well, first thing is we're going to trace how high up we go. Well, if I'm looking, it says I'm going, well, 1 doesn't look like the right number, so it must be 300. So the change in y is going to be 300 miles. And then now, I know I go up by 300. I got to figure out how far do I go over. Well, I look at the over, and it's going from 0 to 1. So that means 1 hour. So right now, I know that the airplane is traveling 300 miles in 1 hour. Let's see if it continues to do that. So I was at 300, I go up 300 more, now I'm at 600. The next dot is at 600. So that works. Go over 1, 1 to 2, that is correct. I went over 300, I went up 300 over 1, that's good to go. Let's check one more time. I go from 600, 600 plus 300 is 900, so I'm going to go where 900 would be. So that's 300 more, and that looks good. I'm going to go over 1 more, 2 to 3, that looks good. So again, my rate of change is 300 miles for every hour. If I went up 300 miles and I went over 1 hour, I'd be at 300 miles. If I went up in another 300 miles, well, 300 plus 300, that's 600, and I go over 1 hour, that's 2 hours. And if I continue to do that, at 3 hours, I would travel 900 miles. So in this lesson, what we learned was how to find constant rate of change in the table. All you do is find the change in y, change in x, and change it to a unit rate. And now we just learned how to find rate of change in a graph. All we do is figure out how high we go up on the y and figure out how far we go over on the x. Change in y over the change in x. Hopefully you guys understand that rate of change is the change in y over change in x. That's it for today's video. Make sure you like that video today. Go ahead, smash that notification bell so you get any notification for any video I post. And I hope you guys enjoyed this video. I'll see you tomorrow.